Hi everyone and welcome back to another lab. In today's lab, we will cover how to configure and verify static trunks. Trunking is a fundamental aspect of network configuration as it allows switches to efficiently transport traffic for multiple VLANs over a single link. In complex network environments, configuring static trunks across multiple switches is essential for facilitating inter-VLAN communication and optimizing network performance. There are a couple of protocols that are used for trunk encapsulation in VLAN configuration. And in this lab, we will focus on exploring the configuration of static trunks using .1q encapsulation option. The alternative protocol is called ISL trunking or inter-switch link trunking. And to explain this in simple terms, imagine you have a big highway where cars or data travels. Now, let's say this highway needs to have lanes for different types of cars or different types of VLANs. We have .1q and ISL, and both of them are like different ways to create these lanes. So .1q, it's like adding a small tag to each car to show which lane it belongs to. And this tag doesn't change the car's appearance, but it helps organize them into different lanes. .1q is used in most places because it's simple and works well with different types of cars or devices. And it's like a universal language for organizing traffic, let's say. On the other hand, we have the ISL, and it wraps each car in a special cover that shows its lane. This cover adds more weight and takes up more space, so it's not as efficient. And it's like putting each car in its own special container, which can be bulky. And at some point, ISL used to be popular, especially in certain areas, but now it's not used as much because .1q is simpler and more flexible. Okay, so let's put this into context. .1q is an IEEE standard that inserts a 4-byte VLAN tag into the Ethernet frame header, and it is a more commonly used and widely supported protocol. .1q tags are inserted between the source MAC address and the length or type fields in the Ethernet frame, and it supports VLAN across different vendors' equipment. And finally, .1q trunks can carry traffic for multiple VLANs over a single link. Whereas ISL is a Cisco proprietary protocol for trunking, and it encapsulates the entire Ethernet frame with an additional header and trailer, adding more overhead compared to .1q. ISL tags are inserted into the Ethernet frame, encapsulating the entire frame. And currently, it is less commonly used in today's network and is mostly found in older Cisco equipment. Finally, just to let you know that the ISL method adds 26 bytes of overhead to each frame for the ISL header and trailer. So, regarding the lab objective, we simply aim to configure static trunks across multiple switches to facilitate inter-VLAN communication and to provide connectivity between different departments. So, regarding the lab topology, as you can see on the screen, we have two different layers. We have the access layer and the distribution layer. And you can see the bottom half of the topology is the access layer, where we have switch 1 and switch 2. We have PC1 and PC3 are part of VLAN 10 and part of the IT department. PC1 is connected to switch 1 and PC3 is connected to switch 2. Similarly, with PC2 and PC4, both of them are part of the HR department and the resides in VLAN 20. PC2 is connected to switch 1 and PC4 is connected to switch 2. And what we see here, we have switch 1 and switch 2 are then connected with the distribution layer, and the distribution layer we have switch 3 and switch 4, where they are interconnected with each other, and they are interconnected with switch 1 and switch 2. So the links from the access layer to the distribution layer are going to operate in trunk mode, whereas the links from the access layer to the end hosts, these links will operate in access mode. Okay, so with that being said, let's move into the switch VLAN table. So I'm going to scroll a little bit to the right. And in here, we can see we have the device name, switch 1, switch 2, switch 3, switch 4. We have the interface ID, all the interfaces that will be used in this lab. And then we have the interface mode, which defines the operation status of each link. So for example, gig Ethernet 01, which is connected to switch 3, is going to operate in trunk mode and is going to allow VLAN 10 and 20. The same applies for gig Ethernet 02. And we have fast Ethernet 01 and fast Ethernet 02. Both of them will operate in access mode. Fast Ethernet 01 will participate in VLAN 10, whereas Fast Ethernet 02 will be participating in VLAN 20. The same applies for Switch 2 and Switch 3 and Switch 4. Let's move into the SVI table, and here we are going to create a couple of SVI interfaces. So on switch 3, we will have a couple of SVIs, one SVI for VLAN 10, and the IP address for this SVI will be 192.168.10.3, and the subnet mask is /24. Similarly, with VLAN 20, we are going to create another SVI for VLAN 20, and the IP address is going to be 192.168.20.3 with /24 subnet mask. And similarly with switch 4, we will have an additional two SVIs. So the first one for SVI 10, and the IP address is 192.168.10.4 with /24 subnet mask. And the same applies for VLAN 20, where we are going to apply 192.168.20.4, and the subnet mask is going to also be /24. Finally, where we can find the host IPv4 address table. By the way, this is already pre-configured on each host from the packet tracer, so we are not going to cover this step, but just to let you know that each computer is already pre-configured with the following IPv4 addresses. So PC1, fast Ethernet 0, we can see that the IPv4 address that has been assigned to this PC is 192.168.10.10, and the subnet mask is /24, and this is going to be part of VLAN 10, and the default gateway is the switch 3 SVI 10. And the same applies for the rest of the PCs as well. So next, let's move into the lab task. And first thing is first, the first task is to obviously build the lab according to the topology and do all the connections according to the provided topology. And once you've done that, then we can connect to the CLI of each device and then change the host name so that when we apply configuration changes, we know which device we are on. And then we move to step number 3, where we will create some VLANs on switch 1, switch 2, switch 3, and switch 4. And we will also create a couple of SVIs, but these configurations will be only applied for switch 3 and switch 4. So the next step is to do some trunk configuration, and we have a couple of subtasks under this step. So the first subtask is on switch 1 and switch 2. We need to configure a couple of interfaces. These are the gig Ethernet 01 and the gig Ethernet 02, and we will force each interface to operate in trunk mode, and we will set the allowed VLANs to only allow VLAN 10 and VLAN 20. And we will also include the interface description. We will verify trunk configuration and check that the admin operation of the interface is actually using trunk. And we will also set the native VLAN to 10. instead of their default native VLAN, which is 1. Moving to the second subtask is on switch 3 and switch 4. We will be configuring 3 interfaces. So we have fast Ethernet 01, gig Ethernet 01, and gig Ethernet 02. And the first task that we will need to do is to set the trunk encapsulation to .1q, and then we will repeat the same configuration as what we have done for switch 1 and switch 2. Next, we will then move to the access ports configuration, and the access ports are part of the switch 1 and switch 2. So we will mainly configure fast Ethernet 01 and fast Ethernet 02 interfaces, and each interface should reside in the appropriate VLAN, and we're going to force each interface to operate in access mode. And then after that, we will verify our configuration, which is something that I call in-flight checks. And then next, the end host configuration, as I mentioned earlier, guys, this step has already been done. But if you are building the lab yourself and if you're starting from scratch, then obviously you would need to tackle this step. Next, we move to step number 7, where we will perform some connectivity test between devices within the same VLAN. For example, we have PC1 that is connected to switch 1 that is going to ping PC3 that is connected to switch 2. And similarly with PC2 that is connected to switch 1, we will initiate some ping from PC2 to PC4, and we know that PC4 is then connected to switch 2. And we would check if the ping is successful. If it's not successful, we would do some further troubleshooting. And if it's successful, we then move to step number 8. And step number 8, we will test some inter-VLAN communication, where we are going to initiate a ping test from PC1 to PC4. And we know that PC1 is part of the IT department, whereas PC4 is part of the HR department. And we would check if the connectivity is actually working or not. And if it's not working, we will need to explain why it's not working. And then we need to move to step number 9, where we will then enable IP routing on switch 3 and switch 4, because both switches are layer 3 switches, so they have layer 2 and layer 3 capability. And then we will move to step number 10, and this is when we just do final verification. If all pings have been successful, then we can go ahead and save the configuration. Otherwise, we can do some further troubleshooting, and that would be the end of the lab. Again, everyone, we get to the point where I ask you to pause the video and give this a go yourself if you want to test your knowledge and skills. So in the video description, I included the lab task and the lab document so that you can download it and practice at your own pace. And I also included 2 packet tracer labs. So the first one is the pre-configuration, which is for those who want the lab ready to go for practice. And the other packet tracer file is for the post configuration, which is for those who want to have the full solution, and they can then compare their configurations with mine. So what I'm going to do next, I'm going to go through the lab tasks and then walk you through the solutions for this lab. I will log into each device to tackle step 2 and change the host name accordingly. So I'm going to start with switch 1. So I'm going to go to global mode, and I would say host name switch 1, move to switch 2. And then do the same thing on switch 3. And finally switch 4. Okay, so let's move into step number 3, where we will be doing some VLAN configuration and SVI configurations. So we're going to start with switch 1, and I'm going to go back to the CLI of switch 1, and I'll start with VLAN 10, and I'm going to name that VLAN to IT department. Do the same thing for VLAN 20, and this VLAN is going to be called HR department. Let's just verify this quickly. You can see that both VLANs have been created. However, none of these have been assigned to a physical interface yet. Let's do the same thing on switch 2. And let's do quick verification by issuing show VLAN brief, and the config has been taken effect. So let's move into switch 3. Right, these two VLANs have been created, and what we can do next is we can create the SVI for switch 3, the SVI interfaces for VLAN 10 and VLAN 20. So I'll go back to config global, and I would say interface VLAN 10, and I would set the IP address to 192.168.10.3, and the subnet mask is /24, which is 255.255.255.0. And then let's do the same thing for VLAN 20. And the IP address for VLAN for SVI 20 is 192.168.20.3 on switch 3. So let's do the in-flight checks. And you can see that these two SVI interfaces have been created. However, it is in the up-down state, and the reason being is because these two VLANs are not associated with any interface yet. So let's do the same thing on switch 4. So in here, I will create the VLANs first. So VLAN 10, and I'm going to name that to IT department. And then do the same thing for VLAN 20. And that is going to be HR department. And then exit one level and go to interface VLAN 10. Set the IP interface to 192.168.10.4, and the subnet mask is going to be /24. Do the same thing for VLAN 20. And VLAN 20 or SVI 20 is going to be 192.168.20.4/24. So if I issue the show IP interface brief, we can see both interfaces have been configured. Another command, if you want, just for your information that you can use, is the pipe, where you can filter the output. We can issue the include command, which is just include, and then you can just put something like LAN, for example, and you can see that all the interfaces that has this variable or this word will then pop up, as you can see on the screen. So next, let's move into step 4, where we do some trunk configuration, and we're going to start that by tackling switch 1 and switch 2. So I'm going to go back to switch 1, and gonna go back to global config, and I'm gonna use the interface range command to configure two interfaces simultaneously. So it's going to be interface range gig ethernet 0/1-2. And the first command I will use is the switch port mode trunk. This forces both interfaces to operate in trunk mode statically. And then I'm going to set only the allowed VLAN to 10 and 20. So I would say switch port trunk allowed VLAN 10. And then if you want to add more VLANs, you can just add the comma and just add 20. And then if you want to add more, then you can add another comma and then add 30, so on and so forth. But in this, based on this tutorial and this lab, we're only configuring two VLANs, and these are 10 and 20. So I'm going to hit enter. And then we're gonna hit the or set the description for these two interfaces, and we're gonna say link to distribution switch. So I will hit end, and I am going to do some in-flight checks. So the first command where we can use is show interface or show interfaces trunk. And here we can see that we have two interfaces that are operating in trunk mode, and these are the gig ethernet 0/1 and 0/2. Both of them are statically configured because the mode is set to on. It means that you've configured them statically. The encapsulation method is using .1q, and the current status, both of them are in trunking or trunk mode. The current native VLAN is 1. I think the next task is to change that native VLAN from the default VLAN 1 to VLAN 10. You can see here under this section that the allowed VLANs on the trunk on both interfaces, gig ethernet 0/1 and gig ethernet 0/2, are only 10 and 20. If you wanted to check the actual configuration for both interfaces, what we can do, we can say show running config, and then pipe, and you want to include the word section, gig ethernet 0 / and then I want to include everything after the slash. So the star is part of regex character, which implies that I want this word to match anything in the running config. So if I hit enter, you will get a return for these two interfaces, and you can see that this is the current config for both interfaces. So interface gig ethernet 0/1 is configured with description, link to distribution switch, switch trunk allowed VLAN 10 and 20, and the switch port mode is trunk. It's the same configuration for gig ethernet 0/2. We can also do another in-flight checks, which is interface, which is show interface gig ethernet 0/1, and then we need to include the word switch port, and that will tell us this is the name of the port, the switch port is being enabled, and the current operation mode is set to trunk. The encapsulation method is .1q, and the current trunking native mode VLAN is set to 1. That will change, and there is no voice VLAN on that interface. And you get other information that might be helpful when you do some troubleshooting. So this is switch 1. Let's do the same thing for switch 2. So go back to global config and then use the interface range command, and I would say gig ethernet 0/1-2, and then we're going to force the switch port to operate in trunk, and then we're going to say switch port trunk allowed VLAN 10 and 20. Finally, we're going to set the description to link to distribution switch. Again, we can do in-flight checks. So say do show interface trunk, and we get similar output to the output that we got from switch 1. So the next task is to set the native VLAN from 1 to 10. So I will start with switch 1. Go back to global config. And I would say switch port trunk native VLAN 10. And you will get a lot of error messages from CDP and whatnot, and you will find spanning trees complaining, etc., etc. And the reason being is because there is inconsistency between the native VLAN on both ends of the link. So one end of the link is saying that the native VLAN is 1, and the other end of the link is saying the native VLAN is 10. And this is not recommended, and this has to be quite consistent across your network. So you are not going to clear these records, or sorry, we are not going to get rid of these syslog messages until both native VLAN are matching. So I will do some in-flight checks. So I would say show interface trunk, and you can see that this time that the native VLAN has changed from 1 to 10. Let's do the same thing on switch 2. So since I am in interface range mode, I can simply say switch port trunk native VLAN 10. And again, we're going to get pretty much similar error messages or syslog messages. And I'm just going to do some in-flight checks. And I will say show interface trunk. And you can see that the native VLAN has changed from 1 to 10 on switch 2. Let's jump into switch 3 and do some configurations. Okay, so I'm going to start with using the interface range command, and I'm going to use 3 interfaces. So I'll say interface range gig ethernet 0/1-2, comma, and fast ethernet 0/1. I will force the trunk encapsulation to use .1q. If you put the question mark after this command, the content sensitive help, it should give you the list of options that you can use for this particular command for that particular switch that you are on. And at the moment, we can only see that the current method that you can use for trunking encapsulation is .1q. There are some switches that will show you the other protocol, that is the ISL, and also will give you the ability to negotiate the trunking encapsulation. But for this platform, we are gonna use .1q because that's the only option that we have. So I'm just gonna go with this. And then we will force the both interfaces, or the triple interfaces, to actually use trunk, static trunk. So we're gonna say switch port mode trunk. And then I am going to set the allowed VLAN on all trunks to be 10 and 20. So switch port trunk allowed VLAN 10 and 20. And then I will say interface range gig ethernet 0/1 and 2. And the reason why I'm doing this is because I wanted to set the description for Gig Ethernet 01 and 02. These two interfaces are going back to the access layer. So I will say the description is going to be link to access switch. And then I will change from this range Gig Ethernet interface to interface fast Ethernet 0/1. And I will set the description to link to switch 4. And at this point, we are good to go with regards to the in-flight checks. So the first thing that I'm going to check is the interface trunk. You can see the current native VLAN is set to 1, and hence why we get a lot of error messages. I'm going to tackle that next. But you can see that we have fast Ethernet 01, Gig Ethernet 01, and Gig Ethernet 02. All of them are configured statically or trunking using the static method. And all of the encapsulation, all of the interfaces are using .1q encapsulation method. And the current status is set to trunking. And the allowed VLANs are 10 and 20 on all interfaces that are operating as trunk on that switch. So let's do the same thing for switch 4. So I will go to global config and I'm going to do the same thing, interface range, Gig Ethernet 0/1-2. And also I want to include fast Ethernet 01. And we will say switch port trunk encapsulation .1q, switch port mode trunk, switch port trunk allowed VLAN 10 and 20. And then we will use this command to only specify Gig Ethernet 01 and 02 to change the description. And we will say links or link to access switch, and then up arrow that and just use the fast Ethernet 01 and then change the description to link to switch 3. Let's do quickly in-flight checks. So say show interface trunk. You can see that this is the current status for each of the interfaces. Again, this is what we expecting. And let's just move into the next one where we are going to set the native VLAN on switch 3 and switch 4. So go back to switch 3, use the interface range command again, Gig Ethernet 0/1-2 and fast Ethernet 0/1. And to change the native VLAN, we will need to say switch port trunk native VLAN 10. Okay, let's move into switch 4. Okay, as soon as we manage to fix the native VLAN, we can see that the received the spanning tree syslog message indicating that the port consistency has been restored, and the reason being is because the native VLAN is now matching. So if I perform some in-flight checks, so I would say show interface trunk, you can see that now the VLAN, the native VLAN is 10. If I issue the show IP interface brief, we can see that both VLANs now, or SVIs, are in the up state. So we have interface VLAN 10 and interface VLAN 20. Both of them are in the up state. Let's do the same thing for switch 3 since we haven't done that. So I'll just end. I would issue show IP interface brief. And you can see that both SVIs are in the up state as well. So if you wanted to do further in-flight checks, what you can do, you can say show running config and then pipe section interface gigabit Ethernet 0 slash and then add the star key or the asterisk, and then that will show you pretty much anything that matches this variable. Whereas if you want to be kind of like specific about a particular section, then you can use this command, and then you need to specify the one. So you have interface gig ethernet 0 slash 1, and that will show you only a single section of the current config. So as you can see on the screen. Next, let's move into step number 5, where we are going to tackle the access port configuration. So in switch 1 and switch 2, we need to configure fast Ethernet 01 and fast Ethernet 02 on both switches to enable each interface to operate in access mode and associate it with the appropriate VLAN. So I'll go back to switch 1. And I'm going to say interface fast Ethernet 01, switch port mode access, switch port access VLAN 10. Let's do the same thing for fast Ethernet 02. And let's do some verification. Show VLAN brief, and this time we can see that there is an association between the port and the VLAN in question. Let's do the same thing quickly on switch 2. Let's do in-flight checks. And fast Ethernet 01 is part of VLAN 10, fast Ethernet 02 is part of VLAN 20. Let's do another in-flight checks, and I'm going to say show interface fast Ethernet 0 slash 1 switch port. And here we can see the name of the interface ID is fast Ethernet 01. Switch port is being enabled and currently is being configured as to operate in access mode. And what we see here is part of VLAN 10, and there is no voice VLAN that is being configured on that interface. And you can see that the rest of the information can be helpful, especially when you do some troubleshooting as well. So the next step is the step where we do some configuration on each PC, which is the end host configuration. I already have done this step, and what I'll do, I'll just show you that each computer has its own IPv4 address. So if I go to config, you can see this is the default gateway, but if I go to desktop and if I go to the CLI and issue ipconfig, you can see that the current IPv4 address is being configured with 192.168.10.10/24, and this is the default gateway, which is the SVI 10 on switch 3. So I'll do the same thing for PC2. And PC4. And finally PC3. Go to desktop and then command prompt, and from there we issue the ipconfig, and here we get the IPv4 address information. Next, we will be tackling step 7, where we will do some connectivity tests, and the first connectivity test that we will do is trying to ping from PC1 to PC3. So let's do this. So PC1, we need to get PC3, and we will try to ping 192.168.10.11. And sure enough, there is reachability and connectivity. Let's do the same thing with VLAN 20. So from PC4, let's just like do it the other way around this time. So I'm going to say ping 192.168.20.10, and the rest connectivity, as you can see on the screen. So the next step is step number 8, where we perform some inter-VLAN communication tests, and we will initiate some pings from PC1 to PC4. So if I click on PC1 and let's get PC4 as well. So we would issue ping 192.168.20.11. Okay, so as you can see on the screen, the ping has failed, and the reason why it failed is because the distribution switches currently are not routing traffic between different VLANs. And in order for us to do that, we would need to issue a command called IP routing. And this is the reason why the distribution switches, or switch 3 and switch 4, are not able to switch traffic between different VLANs or route traffic between different networks. So to fix this, we would need to go back to switch 3 and switch 4 as well, but we'll do that after. And then we're going to go to config mode, and here we would say IP routing. And let's do the same thing for switch 4. And let's get PC1 and PC4 back. And let's up arrow this, and let's try again. And you can see that this time we get 50% of the test successful, but if we repeat that again, we should get 100% this time. So there is inter-VLAN communication between the HR department and the IT department. So that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn on notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.